Welcome to the new Chemist. We're glad you're listening. Feel free to download this podcast on Google Podcasts, Apple Podcasts, and Spotify. Here on the new Chemist, we discuss chemistry, which simply put is the science of change, as well as careers, community research, and COVID-19. We're happy you're tuning in. My guest today is Dr. Todd Golub. Thanks for joining me today. It is good to hear from you. Just briefly, I'll inform my audience about you. Dr. Todd Golub is a founding core member of the Broad Institute of Harvard and MIT, and serves as the Institute's Chief Scientific Officer and Director of its Cancer Program. He is also the Director of the Gerstner Center for Cancer Diagnostics at the Broad Institute. He joined the faculty at the Dana-Farber Cancer Institute at Harvard Medical School in 1997. At the same time, he served as the leader of cancer genomics at the Whitehead Institute and MIT Center for Genome Research, which evolved into the cancer program at the Broad Institute, which he has directed since 2004. Dr. Golub is currently the Charles A. Dana Investigator in Human Cancer Genetics at the Dana-Farber Cancer Institute and Professor of Pediatrics at Harvard Medical School. He is the recipient of multiple awards, including the Erasmus Hematology Award, the Richard and Hinda Rosenthal Memorial Award, and the Outstanding Achievement Award from the American Association for Cancer Research, the Paul Marks Prize for Cancer Research, the E. Med Johnson Award from the Society for Pediatric Research, and the Judson Darland Prize for Outstanding Achievement in Clinical Investigation from the American Philosophical Society. Dr. Golub has served in the scientific advisory boards of numerous organizations, including serving as chair of St. Jude's Children's Research Hospital and the board of scientific advisors of the National Cancer Institute. Please welcome Dr. Todd Golub. Okay, Dr. Golub, thanks for joining me today. It is good to have you on. So, given all your responsibilities and accomplishments, I thought it would be good to have you as a guest on this podcast, serving at one of the leading institutes at Harvard and MIT. So my first question for you is, what have been your longstanding interests in the field of science?
Well, first, David, it's great to participate in your podcast. It's great that you're doing this, and I'm happy to be here. So I have had a longstanding interest in this interface between medicine and basic science, and that just continues to get more and more interesting as more opportunities for translating what we're learning in basic science labs into the clinic are availing themselves. It's just really an exciting time for an opportunity to have real impact of science on patients.
Okay, yeah, that's good. That's good. So, along with that, in that same realm, my question to you is, given all your responsibilities and accomplishments, how do you maintain view of the bigger picture in your career and in your life in general? Like, how do you see the forests amidst the trees? How do you see like the entire periodic table, even though you have to deal with different elements or whatever the case may be? How do you see or maintain view of the bigger picture, especially when you face obstacles and challenges?
I think getting this balance right of the big picture and the focused details is the most important thing in science, and the hardest at the same time to do. My view is that the big picture is super critical, because you need the big view of where you're going and why you're bothering to go there, because otherwise, what's the point of a particular experiment if it's not taking you someplace you want to go, whether that's a concrete goal of trying to cure some disease like cancer that I'm particularly interested in, or if you're trying to go down the path of unfettered discovery to discover something that's fundamentally new. Um, Having the big picture is critical. How do you do that? I'm not sure I have a recipe, except that the question that I like to ask myself and members of my lab all the time is, let's imagine that the experiment that you're planning now were to be as successful as you hope it will be.
Okay.
Will it make a difference? And will people care? In my view, the worst possible experiment or project is one that's successful in the narrow sense, but nobody cares. Nobody pays attention to it, doesn't really move the needle, doesn't impact the field. And so there we shouldn't be so excited about a project that is, you know, successful in some way, but doesn't really advance the field. I'd rather strike out and not be successful on a really important project that has the potential to matter than do something that just doesn't make any difference. So I think trying to keep that eye on the ball on the big problem you're trying to solve and not be too distracted or demoralized when the shorter term obstacles pop up, as they always do.
Yeah.
The goal isn't to solve the short term obstacles and problems. The goal is to solve some bigger picture question and persevere through the roadblocks that get in your way.
Yeah, I completely agree. Perseverance is very important, especially in this time where a lot of people are facing different challenges, even in the academic sense, with classes being in a different format from what they're used to, or in the economic sense with the loss of jobs. So, along the same lines, how have you been adaptive and or creative in the field of science? You work at one of the most prestigious schools. How have you been adaptive or creative? What project that you are currently working on, or have worked on? What project would you say has been like the hallmark of your creativity, if you had to label one as such?
Yeah. Well, I'm so glad you asked this question about creativity because I think creativity is just at the heart of pretty much all great science,
Okay.
any aspect of science. And I think that concept of creativity comes as a surprise to many. I think many non-scientists think about science as, oh, you must be really brilliant and or have kind of encyclopedic knowledge of scientific facts, and that's what they think science is: being a master of the universe of scientific details. And I suppose that stuff doesn't hurt, but it's certainly not enough. And so I think of what's most important in science is what you said, and that's creative thinking, thinking about a new approach to an old problem. For example, really trying to think in novel, out of the box kind of ways. That's just super critical. And I think, I maybe have an extreme view of this, but I think that scientists should be surrounding themselves with other creative people, non-scientists, artists, for example. So, with that in mind, I helped start an artist in residence program at the Broad Institute,
Okay.
where we bring in every year one or two artists who are creative in their way. They're trying to look at the world through a new lens
Mm-hmm.
in their way and in their own language. And so we bring them in and have them hang out at the Broad Institute and talk to scientists with the hope that that sort of creative thinking very indirectly will have a benefit on the creative thinking of scientists at the Broad.
Okay, wow, that's commendable. So my question to you is along the same lines. So it's quite clear that you have been successful in terms of in the additive process when it comes to research and projects in your lab. So how do you go about coming up with ideas for research? Do you like reference old literature and review the previous literature and get insight from the past, or is it just you get a spark of insight or innovation? How do you go about coming up with new ideas for you to do research on you in your lab?
So that's an interesting question, and I don't have a process for it.
Okay.
And I would say that the steps in getting to a great idea for a new project, at least for me, tends to be kind of long and hard
Okay.
and involve discarding a lot of ideas that maybe at first seemed like they were awesome, but then on further scrutiny, either by me or more commonly by someone in the lab, a postdoc or a student, and other scientists, when they press on that idea, come to discover, it's not actually a great idea, or it's a great idea in principle, but in practice, there's no way to really actualize it.
Okay.
So, and I think this is sometimes frustrating to people, like new people starting, relatively early in their research careers, who have this expectation that, oh, these ideas for a great project are supposed to come really easily, and you should be able to go quickly from the kernel of an idea to the execution of a project. And they get frustrated when this process of refining and pressing on an idea until you get it really right, they get frustrated when that takes time. And I think that amount of time, whatever it takes, is well worth it,
Okay.
rather than rushing to just start executing on a project idea before you've really thought about its potential upside
Okay.
and the potential risks with it. Now, it's also an interesting question. How does that process of coming up with a great project idea relate to the past versus the future?
Mhm.
On the one hand, if you're totally ignorant of the past, you're at risk of just doing the same experiment someone else has done and failing at it again.
Mhm.
On the other hand, if you're too hamstrung by what's come before and you only base what you're going to do based on the next step that seems obvious given what's already been done, I think that kind of limits your scope.
Okay.
And so for me, most projects actually don't start with a review of the literature. They think in a completely blue sky about what might be possible in the future, um, and then go back and ask, okay, this seems like a really good idea. Has nobody really ever done this before? And then scour the literature to sort it out. I think that's, at least for me, a better order.
Okay.
Start with the big idea and then fit onto that big idea what's come before, rather than try to piece together a project based on the past.
Okay. Yeah, that's good. That's good. So, um, I I would say many people would say or argue that Harvard or MIT, those are good institutions for students to thrive scientifically and intellectually. So, how have you sought, or how did you find this good environment for you to thrive scientifically and intellectually? What did it just happen through serendipity, or was it the grind or grit? How did you go about finding a good environment for you to thrive?
Yeah. So I think this question about scientific environment is really critical,
Okay.
and maybe the most critical thing to think about. Often when people are leaving our group to take up, for example, faculty positions elsewhere, or scientist commission positions in companies, sometimes they come with a spreadsheet that says, okay, here's how many dollars are being offered from this university and that university, and here's how many square feet of space I would have in this position versus that position. What do you think? And my answer is almost invariably, that rarely matters too much. What matters more is the intellectual environment of colleagues and
Mhm.
trainees that you're surrounded by. And if that's awesome, whatever resources available is probably going to be sufficient. If that sucks and you're, on an island, it kind of doesn't matter how much financial resource or how much space you have. It's going to be tough going. So I think this scientific environment question of being, the environment in which there's a collaborative spirit and a critical mass of scientists who are thinking about some similar questions, but not in the identical way.
Mm.
Um, that's what makes for a really ripe um, uh, environment for research. And so you're right. The Boston community is pretty amazing with respect to the large number of faculty and students and trainees and other scientists in this community. And I think that makes us all better. How did I wind up here? Yeah, mostly by serendipity, but just continue to be drawn to it because of this richness of scientific discovery and curiosity and people.
Okay, yeah, that's good. So, in terms of if you had to given all your responsibilities and accomplishments, how are you maintaining a balanced life, or how do you maintain a balanced life?
Well, I'm not sure I can claim to have succeeded in maintaining a balanced life. I
Okay.
think for some people, dividing their life into work and non-work personal life with a bright line between the two is what makes them happy and is effective. My brain doesn't work that way, for better or for worse, and so I tend to think of what I do as a person and as a scientist as a big continuum where sometimes the balance is wrong at
Okay.
any particular time,
Okay.
and then it swings the other direction at a different period of time, and that kind of flexibility uh, works for me. I think one of the skills in developing as a PI that often doesn't come naturally,
Okay.
didn't come naturally to me, but now I've gotten better at it,
Okay.
is how to say no to things,
Okay.
and to really only say yes to those things that you think are going to really drive your own scientific program
Okay.
or have some other kind of positive impact, supporting students and trainees or making the world a better place in some other way. If it doesn't really move the needle in some dimension
Mhm.
that's significant, just say no.
Yeah.
And that is easier said than done, but um, doing that can have a big impact on your sanity and work-life balance for sure.
Wow, that's good. Yeah, I completely agree. For me personally, as a graduate student, like I'm still figuring out balance myself. So, I completely agree. Sometimes balance is a dynamic process. It's not I have achieved it or I have reached it completely. So, um, I after reviewing your profile and seeing all the work that you've done and the impact that you've made, I would say by many standards, people would say you have been successful as a professor in the field. So, what would you attribute to your success? What has been the guiding factor or the impetus on which you have been so successful as a professor?
Yeah, I'm not sure, but I would say that for me, the key to success is um, keeping focused on trying to make progress on a really big and important set of problems and being open to taking that on with colleagues together to solve a really important problem rather than focusing on what am I going to do myself as a professor or as a lab head.
Okay.
Because I think if you didn't think of the world in that way, it turns out you can take on projects and problems that are much more important when you do it collectively and collaboratively and focus on solving the problem rather than doing it just focused on your own lab. And that's been, I think, useful for me to keep that in mind. And if you do that and wind up making scientific progress, it does just fine for your own career.
Mm-hmm.
So it's not like it's falling on your sword to collaborate and to share in, authorship or leadership of a complex project if the project really benefits from that joint leadership. There's plenty of notoriety to go around for everybody. And so that's what I try to keep in mind. If you keep your eye on the goals and take the approach that you're going to do whatever is needed to solve those problems
Mm-hmm.
for the field and ultimately for patients, everything will turn out fine.
Okay. Yeah, that's good. So, um, at the Broad Institute, I noticed there's a lot of collaboration. You mentioned how you even have collaborations from people who may not work directly in the field of science, as you mentioned with the artists in residence. So how have you maintained vision and teamwork in your environment? What has been how have you done that?
Yeah. So I think um, the key to teamwork, I think, is having a goal that everyone is excited about.
Okay.
Feels like there's common cause. Yeah, that's a really important problem that I couldn't solve by myself, but I could be part of solving it together
Yeah.
with others. And so, if the problem you're trying to solve isn't very important,
Mm-hmm.
why put up with the complications of some kind of complex, collaborative, team-based approach to science? Much simpler to do things just in your own group.
Mm-hmm.
But once you realize that actually you can't move the needle in the same way that you can by working together, then the synergistic, collaborative, team-based science is logical for
Okay.
what you would want to do. And you're happy to put up with the, occasional complexities of, yeah, it's sometimes decision making is less straightforward when you have multiple leaders working together to solve a problem than it is if you just have an individual leader. Oh, well, that's part of the cost of taking on a project which, if successful, will really change the world. And that's a trade-off I'm more than willing to take. But that's why, again, getting back to where we started, it's super critical to make sure you're working on the right problems.
Mm-hmm.
Because if you're going to try to organize all this complex interaction and collaboration, but for a project and a goal that doesn't really matter, who needs it?
Yeah, that's true.
And similarly, I think, some people have what I think is a bit of a fantasy that if you simply put people from different disciplines together
Mm-hmm.
in the same building, for example, or on the same floor, or, around a coffee machine, that somehow a beautifully synergistic, multidisciplinary discovery will come out of it.
Mm-hmm.
I don't think that happens very often. And rather, I think the way it works is that if you have a group of people that are aligned in their desire to solve a problem and they're share the view that we should bring whatever discipline and expertise and approach is needed to solve the problem. Then you're well positioned to make multidisciplinary discoveries because you're trying to solve the same problem. You're all rowing together.
Okay. So, taking a shift or switching gears, why did you choose medicine as a field to do your doctoral studies in? Why did you choose to go to med school?
So, like many people, coming out of college, I was torn between should I go to graduate school? Should I go to medical school? Should I do MD, PhD? And I was tortured by that distinction, as many are. In the end, I decided to go to medical school, trying to pack in as much laboratory research as I could as a medical student, um, because I decided that in the end, I was really intrigued by medical problems. I was motivated by wanting to help patients, and I like the idea of the science inside medical challenges, and that to really do that well required really understanding the nature of the problem. So I don't see patients anymore. I don't take care of patients anymore, but I'm really glad that I did medical training because I feel like it helps me understand the problems that are really in need of solutions.
Okay.
It helps me understand what's feasible in a hospital healthcare kind of setting, and that's very rewarding. Because I didn't do a PhD, there are some fundamental gaps in my fund of knowledge
Okay.
that you could say, well, that's a handicap, and it probably is in some ways. On the other hand, sometimes focus training that can happen in a PhD puts the blinders on
Okay.
in a way that overly narrows a focus in a particular area. And so my possibly, naive view of science also has certain upsides in that um, I feel like I've had kind of an open mind to possibility because I haven't been too constrained by having been down an alternate path
Okay.
before.
Okay. Yeah, that's good. Yeah, I could say a lot of people do encounter the challenge where they are pressed between or trying to decide between grad school, med school, and the PhD. Yeah, that is definitely a battle to fight. But you also did pediatrics as your in your residency. Why did you choose pediatrics as opposed to internal medicine or oncology or medical oncology or radiation oncology? Why did you choose pediatrics?
So the honest answer is that I found pediatricians to be really nice people.
Okay.
And we discussed before, the environment that you're in is a really important part of work. And so I liked uh, being surrounded by pediatricians because I thought they were genuine,
Mm-hmm.
nice people, tend to have, compared to other medical disciplines, perhaps not as big an ego as others. And that kind of appealed to me. And of course, I liked interacting with kids and young families. And, um, I like the experience of helping young parents through really difficult emotional challenges, independent of the medicine and the science behind it. I subspecialized in pediatric oncology.
Okay.
And, when young parents are faced with the news that their kid has cancer, that's the worst possible news, most parents can imagine. And so having to break that news to them on the one hand was very difficult and unpleasant. On the other hand, it was one of the things that brought me the greatest satisfaction and as a doctor, because if you can help a family through the darkest period for them and help them see a ray of light and help them understand something really complex and help them see that there's reason for hope without sugarcoating it, then you've really done something personally meaningful, and that brought me a lot of pleasure. And so in an ironic way, that aspect of, delivering bad news is something I miss, because doing that well, I think, can be such a help to patients and families, and doing that poorly, is awful. And so that was a skill I enjoyed developing.
Yeah. I actually have a relative who's a pediatrician, and he echoes some of the same sentiments in that, my dad is a pediatrician. He echoes some of the same sentiments in that one of the things he enjoys seeing is how resilient children can be, even in the midst of facing those challenges with diseases and stuff like that. So,
no, their kids are amazing, both emotionally in what they often, unfortunately, have to endure, and medically, they're amazingly resilient. Their bodies are amazingly resilient and adaptive, and so there's also some really interesting science in there as well.
I agree. So as we conclude, do you have any advice to those wanting to pursue the field you are currently working in, studying in, matriculating in? If you had to give advice to whether it be scientists who are facing challenges in the midst of COVID, or undergraduates who aspire to a profession that you are working in any of those areas, what advice would you give?
I would say that to remind everyone to think about impact and what can you do with your life that will maximize your impact in a field, on the world, and then do whatever it takes to have that impact. If you're heading down a path that in science that feels like, even if in the short term it's successful, the impact is minimal, that's not great. And it's worth stepping back and asking, what could I be doing in a different direction that can't guarantee big impact? Because if you want guarantees, you're not going to have big impact. The guaranteed successes gives you incremental success. It doesn't give you the really dramatic impact that I think we'd all like to have. And so that means being willing to take on some risk. And I think that's okay and good. But just make sure that the potential for big impact is there, because if it's not, you should be using your talent and your brilliance and your creativity and your motivation and hard work. You should be putting all those skills to work on something more important.
I agree. So, Dr. Golub, thank you so much for joining me today. It was good to have you on. Thanks for listening. We're glad you were able to tune into this podcast. Once again, this is the New Chemist, where we discuss chemistry, which simply put is the science of change, as well as the other sciences, careers, community, research, and COVID-19. Thanks again for listening. Note, the views on this podcast represent those of my guests and I.